you are going to write down to which homologous series it belongs to, and you're going to write down the molecular formula. You don't have to do that. That's going to take too long. Okay, so the first one here, you see the double bonds. So we're going to say that is the alkenes. And then there's 4 carbons and there's 8 hydrogens. Next one, you see the double bond. So it's the alkenes, 4 carbons and 8 hydrogens. And immediately you can see they are isomers of one another. Okay, because they have the same molecular formula, but something is different. You can see the parent chain length is different. So they are chain isomers. Right, next one, butene. Hello? Ene tells you it's an alkene. But tells you there's 4 carbons. So then there's 8 hydrogens. How did I know for C4H8? Because I know the alkenes have a general formula of that. So if the N is 4 from the but, then the hydrogens is 8. Then I see all of that, and that catches my eye. That's COOH. That says it is a carboxylic acid. And there's 1, 2, 3, 4 carbons. There is 8 hydrogens, and there's 2 oxygens. Then I see methyl propanoate. It tells me it's an ester. Let's draw it. Propanoate means 3 carbons. Ester means double bond OO. And meth means 1 carbon. So that means I have C4H, 1, 2, 3, 4, 5, 6, 7, 8, and 2 oxygens. So I can immediately see these 2 are isomers of one another. This one is an ester, carboxylic acid, functional isomers. This one here is a double bond O in the middle there, so it means it's a ketone. C4H8O. And then this one here is an alkene. And this is C5H10. No, so I, at the end of my pregnancy, I get more and more allergic to life. Pregnancy is just not as wonderful as it seems. So I'm allergic to my rings. You'll see I take it off often. I can only wear these earrings. My eyes are watering the whole time because I'm allergic to my makeup. So that just makes it worse. It changes. My nose bleeds every day, the whole day. It doesn't look like you're wearing it. Because it's all cried off from the everything. Yeah. Anyway, that's life. Okay. Right. So the first thing that I did is I wrote down to which homologous series they all belong to and their molecular formula. Alright, now I read the question. It says, write down the letter that represents a chain isomer of compound A. Okay, so where's compound A? There's A. That is the molecular formula. So it must have exactly the same molecular formula, either this one or that one. Chain isomer means the length of the parent chain must be different. This one is 4. This one is also 4. But means 4. So it cannot be this one. This one's length is 3. Can you see that the double bond did not change? The position did not change. So that is why they can be chain isomers. If this position was somewhere else, it would have been wrong. Okay. So this answer is B. Next one. The positional isomer of compound A. So again, there's A. This is the molecular formula. Either that one or that one. The positional, so the position of the weird thing must be on a different place. That is the weird thing on the first one. So this would have been but 1-ene. So then it can't be but 1-ene again. It must be but 2-ene. So the answer is C. Next one, a functional isomer of compound D. That is D. The only one that has the same molecular formula is E. And are they functional isomers? Yes, because it's a carboxylic acid and it is an ester. This is E. Yes?
Yeah,
Write down the IUPAC name of compound B. So one B's name. Bukamusa, let's start with you. What did you say is B's name? One dimethyl. Okay, and then? Did you highlight?
Yes.
Did you highlight this thing to be your parent chain? The whole thing. And then this is your side chain. How many methyls do you see? Yes. One. So why do you have dimethyl? Never look at the hydrogens. Okay, so there's one methyl. Where is the methyl on the second carbon? Can it be on the third carbon? No, then it's going to be butene. Yeah, can it be on the first one? No, because then it's again going to be butene. So you can only be on the second one, so you do not have to write 2-methyl. You can, but you do not have to write 2. They did accept it 2 years ago, 3 years ago. Okay, methyl, and then there's 3 carbons on our parent chain, so it's prop. Do you have to say prop 1E? No. Because if it's there, it's going to be again on the first one. So you can just say propene. Methyl, propene. That's fine, it will still be exactly the same name. On the second carbon. Yes? No, but you have to start counting from that side because it's closest to the a functional group. You have to start count there. Okay, next question. Write down the molecular formula of compound C. We've already done that. That is C4H8. Write down the structural formula of compound E. We've actually done that. But remember, when you write down the structural formula, you must show all of the hydrogens. Even if you leave out one hydrogen, they deduct a mark. Not just lines. You have to. What did he say?
Yeah, please.
So you have to show all of the hydrogens. If you look at this question comes from a past paper. How many times do they ask you to draw a structural formula? Literally twice. So you do not have to write a lot of hydrogens out. So the time that they do ask you that, just take the time and write all of the hydrogens. Alright, next one. Write down the structural formula of the functional group of compound C. There's C. Now C is actually, this is question 5. C actually looks like this, right? If you show that, you don't get a mark. Because they didn't ask the structural formula for the whole thing. They asked for the structural formula of the functional group. That is what you show. Only that. If you show more, it's wrong. If you show less, it's wrong. Only of the functional group. No hydrogens, because it's not ethene. Only the functional group. Yes, if that was not there, then you'd have written the whole thing. Okay, but because they said of the functional group, only that. Now, you're not going to fill in more C's there. You're not going to fill in H's. You are going to show the lines to show more bonds can follow and any more bonds can follow. You will see some people sometimes put brackets around it to show that is the functional group and the rest can follow. But you don't have to. It's accepted if you do. Say again? No, not the whole thing. No. Alright, then 6. Write down the opaque name of the compound that contains a carboxyl group. So here they check 2 things. They check to see, do you know what is a carboxyl group? And then can you write a name? Okay, so where are we with our questions? Refilu, where will you find a carboxyl group? At number D, at the carboxylic acid. So first of all, you have to know that is a carboxyl group. Now you have to give the name. So there's 1, 2, 3, 4 carbons. So what will the name be? Butanoic acid. Alright, question 7 they ask. Is compound A saturated or unsaturated? Give a reason for your answer, Senumta. Unsaturated, why? Yes, mooi. So it is unsaturated because it has, you could have said double, or you could have said multiple bonds. Don't just stop there. Between carbon atoms, or you could have said between 2 carbon atoms. Yes, Botumelu. Ish. Your handwriting. No, it's wrong. Because that means it's a carboxylic acid, so it's a uric acid. There's no E. Where do you see the E? No, I'm not saying about this. I'm saying about extra. Yes, sorry. You must have 4 carbons. But I'm just thinking it was the simple. Let's count how many carbons is it? 1, 2, 3. 4. Yes. What did I say yesterday about people that don't count that carbon? What day is this?
Yesterday,
Oh.
what do you say about these people, man?
I said there's always people that do not count that first carbon. Where is that people?
They don't come to the team. Okay.
So, I don't know
There's the people.
if they say methyl propanoate, right? So it's 3, then the structural formula, and then the O, and then the 2 C's.
Methyl.
No, 1.
Okay.
So the structural formula, and then what follows is the methyl or the ethyl.
Are you Koza?
Yeah,
That clicks. Yeah, but suitors don't click like that. Oh, those clicks are next level. It is. Remember, I had Koza, like you guys had Sutu in primary school? Ne? I did Koza in primary school. Yes, and then we had to practice those clicks. I had Koza as a subject. I come from the Western Cape. Free State, you have Sutu. I think grade 1 to 7 or grade 3 to 7. Here? Wow. Difficult. But we had a, I'm recording now. But we had a teacher, so it was a white lady that taught us it, but she had a big birthmark here. And we called it Ifleki. Spal like sis. Alright, but it was funny. Huh? Yes. Anyway, alright. Next one it says, write down the name of the homologous series to which compound. No. Write down the name of the homologous series to which compound B belongs to Karabu. Belongs to the?
I know it is alkenes.
It's literally written there. What did you write? Okay. Alright. Next one. I just quickly want to finish the Says that which one of the following compounds represents a ketone And I hope you all can easily and quickly say it is compound. A. Because we're on page 22.
Wait, how did you get to 5? No, I didn't see 5. There's no 5.
We skipped 5 because we haven't done the work yet. Okay, B is an aldehyde, D is an alcohol, and C is a carboxylic acid. Yes? Okay. Consider the compound with a molecular formula C4H10. How many structural isomers does this compound have? Okay, C4H10. Subute. It is an alkene. How did I get to it's an alkene? Because I got CN. No. It's an alkane, sorry. Alkane. CnH2n plus 2. Okay. So we have 1, 2, 3, 4. That is the first one. Right? Then we can have... Can it have a positional isomer? Does it have a weird thing? No. So the position of a weird thing can't be because there's no... Can it have a functional isomer? No, because the functional group can't change. So the only thing we can do is make this 3 like this. Can I make the chain shorter to 2 like that? And have side chains? No, because then it's butane again. What if what? Yes? Ask. Ask. What if? It's fine. I want you to think out loud like that. So there can't be any other way. So it means there's 2 isomers. They are isomers of one another. So it's like you can't have one twin. You understand? If you have isomers of a compound, there must always be 2. You can't have one isomer.
Can you have 4 isomers?
Say again? Yes, you can have more. So if this was the original compound, how many isomers will there be? 1. Like you can't, there's only one of it. So then the answer would have been A. But because there's 2 options of how you can write down that, the answer is B. Yeah, so these 2 will be chain isomers of one another. And that's the only option you have here.
I'll guess 2 more straight away.
Okay, don't guess. Next one, quickly give me the name of that compound. Shh, but go. Maybe they are wrong. They don't get full marks in an exam. It is an extra class from the department. They are giving off videos, but we haven't done the chapter. But maybe you've done it in extra classes. I don't know.
They are recording from YouTube. You remember you sent us previous classes from
Yeah, but I don't know if they're recording this one.
Yeah, this is a part or something.
Maybe they do. Maybe they don't. What's the answer? B. Okay, sure. So I told you. Chemistry question paper, multiple choice is the first question. Second question is this, up until now. Isomers, structural formulas, names, blah, 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 blah. Now we're going to go to the next question, question 3. Now we've actually discussed question 3 fully, grade 11. Okay, so page 23 is, you'll see, then it starts with a question and then multiple choice questions. So it's only page 23 that discusses question 3 in your exam. Okay, what is it all about? Question 3 is all about intermolecular forces. They call that structural and physical properties, but intermolecular forces. Okay, now we have discussed that. We said we looked at London forces, dipole, hydrogen bonding, ion dipole, and we said if you compare London with hydrogen bonding is strong intermolecular forces. So you first state the obvious difference, the two intermolecular forces. Hydrogen bonding is stronger, thus more energy is needed to overcome the intermolecular forces between compound, blah, blah, blah. Thus it will have a higher boiling point. Yes, those 4 bullet points? Same thing here. So I'm just summarizing. There is 3 definitions that you need to know: viscosity, vapor pressure, and boiling point. Now, viscosity, they do not ask a lot. What is viscosity? Is the measure of a liquid's resistance to flow. For example, if you compare honey and water, then honey's viscosity is higher, meaning honey has a stronger intermolecular force. Okay, then the next one that they do ask a lot is vapor pressure. Vapor pressure is the pressure of vapor. Vapor is something that has vaporized, evaporated a gas. The pressure a gas exerts above a liquid, and there's something that is missing here, above a liquid in equilibrium in a closed system. Closed, or you could also say isolated. Okay, so in an isolated or closed system, meaning the lid is closed. Okay, so when the lid is closed, then when you heat up something, it will start to boil, it will start to evaporate, and then at a certain point that vapor will be saturated, meaning nothing can evaporate anymore, and then it will condense, and then it will evaporate and condense, so that is the equilibrium in a closed system. Okay, so that pressure that the vapor exerts on the liquid, that is called vapor pressure. And the stronger the intermolecular forces are, the more difficult it is for a liquid to evaporate. So the stronger the forces are, the stronger the particles are held together, the more difficult it is to evaporate. Okay, so if it's strong forces, then there will be very little vapor particles at the top, so the vapor pressure will be low. So what you can think of in your head is you can say vapor pressure is inversely proportional to intermolecular forces. Weak. Forces can't be low, it can only be weak or strong. But, you cannot use this formula in an answer. When can you use this inversely proportional wording, whatever? When there's actually, when there's actually a formula on your data sheet that has these symbols in them. Do you have a formula on your data sheet with intermolecular forces? No. So you can't use these symbols or this formula in an answer. You can explain it in words. You can say, as the intermolecular forces increase, the vapor pressure decreases.
So maybe if you say there's a formula for that and then you ask for the definition and you just write the formula. Why are you telling us this now, man? I never knew.
Maybe you haven't listened. I don't know. Alright, next one is boiling point. Is the temperature. Now remember, if you do not say the word temperature, you don't get a mark at all. You get 0. So the temperature at which vapor pressure is equal to atmospheric pressure. Okay, by the way. Alright, and again, the higher the vapor pressure, the lower the boiling point, or you can think of it as a boiling point is inversely proportional to vapor pressure, or you can think boiling point is directly proportional to intermolecular forces. The stronger the forces, the higher the boiling point. No, also not. This is also for yourself. Just do understand it. Alright, so last year we only looked at 2 things. Last year we looked at type of intermolecular forces, London versus dipole, whatever, and we looked at molecular mass, how big or how small the molecule is. This year we're going to look at 4 things. We're going to look at the strength of the intermolecular force, the type, the number of functional groups, the surface area, and then the branching. Okay, so here I've summarized it a bit for you. Let's look at intermolecular forces. This is obviously organic chemistry, so we're only going to look at organic compounds like carboxylic acids, alcohols, ketones, aldehydes, esters, alkanes, blah, 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 blah. What?
No, don't put it like this.
Why are you taking me off guard again? What? Thank you, Karabu. I don't know if it's a compliment, but thank you.
See, comfortable.
Other teachers are strict. It's like
Never say that to the principal. Okay, and I'm obviously recording all of this. All right, so carboxylic acids. Okay, we have discussed this already. Carboxylic acids look like this, and we said they have two sites for hydrogen bonding to occur. Two places. You can also use the word places, two sites or two places, or 2 points. Okay, but the formal word is site. Two sites for hydrogen bonding. Whereas if you look at alcohols, they only have one site where hydrogen bonding can occur. That is why carboxylic acids has stronger intermolecular forces than alcohols. The next one is ketones. They have dipole-dipoles. Aldehydes also have dipole-dipoles. Esters also have dipole-dipoles. Okay, this is the order of their strength. It's not a big difference in their strength. Okay, but this is the order. And then alkanes, alkenes, alkynes, all, and there's a K missing, have all London forces because they're all symmetrical.
And they ask that why are they London?
No. Oh, no. They won't. All right.
Wait, what's the difference between the intermolecular forces, even though they are the same intermolecular forces?
These
Like
ones.
say,
No, they won't.
oh.
Okay. So a question would be, for example, explain the difference in boiling point between ethanoic acid and ethanol. Okay? Then you'll say ethanoic acid has a bigger polarity in its functional group, or you can say it will have two sites for hydrogen bonding, and alcohol only has one site for hydrogen bonding. Thus, it has strong intermolecular forces. Thus, more energy is needed to overcome the intermolecular forces between the particles. Thus, the boiling point is higher. So this here is just a small summary of what you're used to writing. This here refers just to the vapor pressure. Okay, so I can either ask about boiling point or vapor pressure. With vapor pressure, you're going to add one more sentence. You're going to say, thus it evaporates at a slower rate. And I want you to add there, at the same temperature. You don't have to say at a slower rate. You can just say it evaporates slower. Okay. I know. Right. Then we have the number of functional groups. Now this one they do not ask a lot. Okay. The two that ask a lot is number 1 and number 3. The most. They do ask number 4 also. But number 2 they don't ask a lot. But maybe this year is the year. We don't know. Okay. The number of functional groups is, let's say you compare propanol with propanediol. So this one has 1 ol and this one has 2 ols. So this one has 1 site for hydrogen bonding and this one has 2 sites for hydrogen bonding. So which one will have a stronger intermolecular force? This one. So stronger intermolecular forces. Blah, blah, blah. Okay, you get the idea? Next one is the chain length, but they don't like to use the word chain length. They prefer it if we use the word surface area. Okay? Or if you use molar mass. Okay? And what we have here is if we compare, let's say, this with this. Alright? So they both have the same number of, the same type of intermolecular force, London. So we can compare them. But this one is a shorter chain than this one. Okay. But we're not going to say it has a shorter chain. We're going to say the surface area is smaller than this one's surface area. Or you're going to say this one's molar mass is smaller than this one's molar mass. So we're not going to mention chain length. We're going to mention surface area or contact surface area or whatever. Okay, and then the last one is a branched chains. So it is where if you compare this one with this one. Okay, why is it a fair comparison? Because two things remain constant. They have the same number of carbons and they're both alkanes. If this one had a double bond in, would it be fair? No. Alright, so the same number of carbons, same functional group. Then this one is more branched. So if you think about building blocks like Lego pieces or blockies that you put on one another, this one you can easily put on one another, right? So that you can make contact, not that it makes contact, but the forces are stronger. Whereas if you have this one, then yes, you can put it there, but what if you have to put something here? It makes it a bit awkward. Okay, so this one is a bigger surface area, so it has fewer branches, contact surface area is bigger, stronger interlinkage forces, blah 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 blah. Chop. If I say if it's, then it is stronger intermolecular forces. Yes. Yeah. Alright, so what you're going to do for homework is page 24. This comes straight out of a past paper. Okay, where you are given 4 compounds. Now let's not label them, let's call them A, B, C and D. So that you don't have to answer the full name every time. You're just going to say compare A with B, whatever. Alright, so this is where you're going to mention those 4 bullet points every time. Okay, but while we still have 15 minutes, let's go to multiple choice questions. It says there, the boiling points of branched alkanes are lower than those of straight chain alkanes. That's what we just did. Containing the same number of carbon atoms because branched alkanes have larger molecular masses. No, because that would be an unfair comparison. Shorter chain lengths. Wait. More electrons? No. Smaller effective molecular surface area. Okay, so ma'am, we wanted to say shorter chain lengths because it does. That's why we do not mention chain lengths. Because if you compare this one with this one, then technically they have the same number of carbons. So people argue they have the same chain lengths. Because when you say shorter chain length, are you referring to the whole one or just the parent chain? What are you referring to? So that's why we don't mention chain lengths, because it's confusing. We spoke about effective molecular surface areas. Sharp. Okay, next one. Which one of the following compounds will have the highest boiling points? Okay, let's check the type of intermolecular forces first. This one looks like an alkane to me, right? An alkane have what type of forces? London. This one I see an OH. Alcohol. Why can't it be an aldehyde? You don't know.
O and H are not there must be an H next to C.
Okay. Yes. Or you can think this carbon has 2 hydrogens and an OH. When aldehyde will only have 1 hydrogen. You see that?
So if that were written
without that, then it can be an aldehyde. Okay, so this is an alcohol. And what type of bond does it have? Hydrogen bonding, and it has one site. Next one here, that. Let's check. Blah, 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 blah. Carbon with 2 hydrogens. And then we have an oxygen somewhere. And then a carbon with 3 hydrogens. So that oxygen can be there. It can't be an ester because it doesn't have 2 oxygens. Can't be a ketone. A ketone would look like that. Can't be an aldehyde, must be at the end. This will be an alcohol. I just showed you. Carbon with 2 hydrogens, right? And then a carbon with 3 hydrogens, those two at the end. So where will this oxygen fit? It can't, well, it can. So it can either be here or it can be there. It's just written very weird. So in my head, this one is also an alcohol, but it is a second degree or a secondary alcohol because it's in the middle. It's not at the end. Say again? Yeah, the carbon bonded to the OH is bonded to 2 other carbons. Alright, now I'm thinking there's a mistake in this question paper. Why am I thinking it? Because it's the exemplar of 2008, meaning it was like a practice question paper. There could have been mistakes. But anyway. Then this one here with the double bond O is a ketone. And a ketone has dipole-dipole forces. So dipole-dipole forces and London forces are the weaker forces. We have hydrogen bonding. So which one is stronger? The one where it's at the end or in the middle?
At the end.
So if it's shielded, it's not that polar. If it's at the end, it is open, so it's very much polar. So the answer is C. Right, next one. Consider the structural formula and the opaque names of each of the compounds below: propane, ethanol, fluoroethane. Okay? Which one of the compounds have the highest vapor pressure at room temperature? Highest vapor pressure means it must have the weakest intermolecular forces, because they are inversely proportional to one another. Okay? Propane will have what type of forces? London. Ethanol, there must be a double bond, by the way. Ethanol is dipole-dipole. If you see a double bond O, dipole-dipole, without a hydrogen anyway. Ethanol will have hydrogen bonding. Ooh, fluoroethane. Okay. No, definitely not hydrogen. But, wait. You want to say London, but fluorine is very electronegative. So it causes this one to be a bit negative on this side and this positive on that side. So this one is on the range of between London and dipole-dipole. Not hydrogen one. So which one will have the weakest forces? Propane with only the hydrogen bonding. So the answer is A. Okay. Which one of the following compounds have the highest boiling point? Where's your potato? Okay, if we look at all of them, they all look like alkanes, right? So all alkanes, the only thing that is different is the length of the chain. The one for the highest boiling point, meaning it must have the strongest intermolecular forces. Which one will have the strongest? A, because it's the longest. Right, next. How many did I give you here? Okay, a lot. A scientist investigates a factor which influences the boiling points of alkanes. Okay. He determines the boiling points of the first 6 straight chain alkanes. Which one of the following is the independent variable in this investigation? Okay, let's see. He looks at a factor that influences the boiling point. So he wants to get to the boiling point. The boiling point is the dependent variable because it's the thing that you measure. Dependent. So the independent thing is the thing that we change. Okay, what did he change? He looked at the boiling points of the first 6 straight chain alkanes. So they are all alkanes. So that is not the thing that he changes. They're all straight chains. So it's not side chains. It's not branching. It's not branching. So they're all straight chains. They're all alkanes. But he looked at the first 6, meaning methane, ethane, propane, butane. All right. So is it boiling point? No. Is it branching? No. Is it functional group? No. They're all alkanes. So here it is literally the chain length. The dependent. So this is the deep. No. Yeah, this is the independent. Independent thing is the thing that you change. Dependent is the thing that you measure. You measure the boiling point. Okay. Yeah. Okay, next one. Which one of the following compounds has the highest boiling point? Let's check. They are all alkanes. Yes. So which one will have the highest boiling point? D. Which one of the following compounds has dipole intermolecular forces between its molecules? I'm so excited about the full box.
Yeah, bro.
You're missing out on.
Yeah, bro. Business, you will be fine.
What cheese? Hoe goed zijn is warm. Oh, hier is aan die braad.
Yeah.
What are you doing here?
This is Annie Brand.
Did you copy? Thank you, Sarah. Alright. Which one of the following isomers has the lowest boiling point? So it has the weakest intermolecular forces.
So it must be the functional lowest.
Yeah, it's BB. Hey.
Okay, so I sense a bit of confusion. What does the brackets indicate? Careful. Do you see a number afterwards? No. So then it's not the same thing over and over again, because how can you have in the middle of something 3 hydrogens? So it's side chains. This one has 1 side chain. This one has 1 side chain. This one has 2 side chains. This one, if you have to draw it, it is 1, 2, 3, 4. 1, 2, 3, 4. And on the third one or the second one, there's a carbon and there's a carbon.
When we were doing the drawings, we didn't do it anymore. For example, when we convert CCC, instead of writing that all one thing, we just write it.
Yeah, but when we did that thing there, like that, it will always have 2 hydrogens. It never had 3 hydrogens. 3 hydrogens tells you it must be a side chain. So this one has the most side chains, so it will have the weakest intermolecular forces.
If it has the most, you know what?
Okay.
We'll make notes. Say there, this 3 means side chain.
More side chains, more.
Weaker intermolecular forces. lower boiling point. So Nomda, did you join us after this chapter in molecular forces? When did you join us last year? June. Yeah, you joined us after. We did into molecular forces. Really? Wow. When did we do it? I thought we did it second term. B, boiling point. Yeah?
Weak intermolecular process and low boiling.
Yes. Right. Next one. Which one of the following compounds have the highest vapor pressure? Highest vapor pressure means weak intermolecular forces. Oi, oi, oi. This first one, COOH, is what? Carboxylic acids, which has 2 sites for hydrogen bonding. The next one here, alcohol, has 1 site for hydrogen bonding. This, well, I wrote 2, sorry. 1. Okay, this one here is a what? Alcohol is written OH. This one is written HO. An aldehyde. And what type of intermolecular forces they have? Dipole. And this last one is an alkane. And it has London. So they ask for the highest vapor pressure, meaning the lowest intermolecular forces, so it will be D. Next one. Yes. Which one of the following compounds has hydrogen bonds between molecules? We have pentanol, anol, aldehyde, no. Pentanone, ketone, no. Pentanoic acid, which has hydrogen bonds. Okay, you don't have to finish the multiple choice, just finish the page 24.